Okay, let's get into it with the tech news. All of these were scraped from the ACM like newsletter thing. And so there's a bunch of them actually. I grabbed ones that I thought were interesting because some of them are like weird, like strange things that I don't understand and don't seem very interesting. I thought the 3D printed coral was entertaining. They're working on a 1 petabit per second transfer speeds, which is pretty spicy. I don't know enough about networking to fully understand what's happening here, but it sounds cool, and that's a lot of data. So we'll post a bunch of these links. What were the? Did you post some?
Yeah.
That you thought were cool?
Some.
You posted some of the drones ones, bro.
Yeah, that passenger drone thing.
Ooh, that's pretty awesome.
There's a video, like down lower.
Yes.
Yeah. They do a test flight.
I think the speakers are on my computer.
It's like an air taxi in, I don't know how to pronounce it, like Guangzhou or something, somewhere in South China.
So it's basically just helicopters, but less expensive.
Yeah, and it's electric. It's like the same design as like an Amazon drone, just really big.
Oh yeah, I think I saw this.
And it flies itself.
The guy
It
inside.
changes directions on you.
Yeah, just like sends you somewhere else. It's like, nah, you ain't going here today.
Redirected to Guantanamo Bay.
No, that's just
Yeah.
no. It's
Kind of
ridiculous.
scary, but kind of cool at the same time.
Yeah, I mean theoretically that makes it better, but it also makes it scarier, and you're like, ah, well, is it worth it? So, I've been reading an interesting book. It's called Army of None, and it talks about autonomous weapons, and it was on Bill Gates' list of like top books on technology. Highly recommend it, especially with the number of autonomous systems and how to keep safe while we keep them going. I want to watch it land. Yeah, it's about to land.
This will go better than the SpaceX landings.
Too soon? Like the image recognition, like if you get this wrong, like, oof.
Yeah, it actually thinks, oh, I'm supposed to land on that pad of concrete.
Oh, this tree looks nice to land on, you know? Wow. Okay. That was pretty lit.
So where are they filming from another drone?
Oh, geez.
Oh, I guess so. Yeah.
Yeah. And then it just goes back and lands.
500 drones self-assemble into one mega drone.
I don't like the shake it has. Oh, that.
Wait, put that in full screen.
What, go back to
I
it.
want to see how much it shakes.
Oh,
That's
yeah.
no
That's-
more than your airplane landing.
That's a little bit.
Yeah, I guess I don't.
Trying to land level on the runway.
I guess it's just more when it's such a small thing to have that much shake. I don't know.
That much jostle.
Yeah, I don't go on airplanes that often. So,
Is that like a fear thing or?
What? That I don't go on airplanes?
Yeah.
No, I just don't go anywhere. Dude, I study CSC. You think I go anywhere? No.
Well, I mean, like,
One time I went downstairs. That was pretty crazy.
I'm saying is if you were to ever travel, would you use an airplane if the
Yeah.
distance was an issue?
No, he's gonna swim the whole way.
This is some cool stuff for machine learning applications. Prediction is machine learning specialty, and having like a good use for it it's pretty cool to see. So if you're interested in this, we'll try and post all the links to the news. Okay. Any other news things that people wanted to look at? There were a lot of them, but
What was the ticklish robot?
No. Is this the one where they added flesh or something?
Oh.
Yeah.
Oh.
Yeah.
Oh,
Flesh.
wow.
It's
Oh,
kind of creepy, but
that's- I don't know how I feel about that.
it's
Yeah.
it's well, the next image, if I remember correctly, is yeah,
Aw,
just kind of
okay, that's more endearing.
yeah. So, oh,
Rather than just some disembodied chunk of ticklish.
so like this. What if devices were covered in
I don't
artificial?
want my phone.
Oh,
Yes. I
Oh.
I don't like this.
It's a novel concept.
This makes me look
Oh man.
This is
I really don't like this.
it replicates.
This is like the phone cover a serial killer would buy.
Yeah, this is like straight. Oh, but see, that's. I guess I don't know what makes it different than just like a capacitive touch thing. Like, because
Oh,
don't
that
they
is
already
kind of
have multiple?
Wow.
Thanks, no parish.
I don't know how to feel about this.
Yeah, if they made it like a different color.
Yeah, just
they're
not
calling it a
skin.
different name.
Hyper-realistic
Hyper-realistic version.
An actual like lab-grown meat slab.
Yeah. Okay.
Mommy, give me the touch capacitive phone cover.
Stop.
Made of human flesh.
Stop it. Hey, wait, they're using my phone. It's pretty garbage, so I'm surprised it's running it because it's really slow. Oh. See, I could see this as being like a new way to use a phone.
A piece of
I mean,
flesh
I
that
think
uses the joystick.
I would think it was really cool if it was like neon green or something.
Yeah, it was like a putty kind of thing.
Yeah, but this is just all sorts of disconcerting.
I don't know.
You just like slap like bologna on a rope.
Yeah, you just slap bologna on a rope. Yeah. No. This is okay, this is just
This is weird.
I wanna oh, so they just okay, well they didn't show any of the good stuff. Where's the goods?
Ugh,
Stop it.
that one had like calluses on it.
Oh, that's weird. It has like a wire system inside of it. You can kind of see.
Wait, stop.
I don't necessarily see the point.
Oh, the point? I have no idea what that point is.
Sometimes science just doesn't need a point.
No,
Sometimes
it
we're
does not.
We're just doing stuff.
So yeah, that's the news.
Sweet.
Glad we could get into that.
I'm gonna buy myself an artificial skin phone.
Yeah, I'm just gonna need to take a seat after that. No. R, because we're going through our
Oh, but
series of programming languages. So we're going to talk about R. It's probably one of my favorite languages. It's my favorite data-based, like data analysis language, because I think it does a lot of things really well, and I like making graphs. So I feel like it's the best, at least for me. And I don't do all the statistics that you can do in this language. You can get like crazy stuff that's way beyond me, but I'll keep it simple. Normally I wouldn't start out with all the links, but I just wanted to put them in there so that we can share this PowerPoint afterwards because it's on Google Slides and then everybody can see where you can learn more about this afterwards. The Derek Bonas, he has like a learn language in one video for literally every language that I could think of. And his videos are in depth and they have good, like they really do cover basically an entire language in one video. It's quite impressive. The only thing I don't like is that he uses light theme, but yeah, I guess it works for his videos.
You could make a version that's literally just his video.
Just his videos, but dark theme. Just call it dark.
We upload, but we like reverse the gradient.
Yeah, duh, jeez. Okay, and then I have some hands-on stuff that we're going to do at the end of this using the iris data set, and basically I just took the code off of the link I showed here. And then the visualization stuff is using a library called ggplot2, which is basically it's like the library for data visualization in R, and when you start to see some of the plots, you'll probably see why. So those are the links. You can check them out afterwards. So, does anybody actually use this thing other than me? And if you've been keeping track of like language use, this is programming languages. I'm assuming that this is probably a little bit related to data science a little bit, but especially because they chose Python, R, and MATLAB. Luckily, R is surpassing MATLAB, which is just, as far as I'm concerned, that's really the only thing that matters, is that every language surpasses MATLAB. But it's in a pretty steady decline. It might be tapering off a little bit recently. Its initial hype isn't as much as it is there, but it's still going strong after, well, this graph shows 10 years. But it's not as popular as Python, but Python has a lot of other stuff it can do, and not just data science. But for being a relatively specific language in terms of data science and what it can do, the fact that it was ranked number 7 on this list of like worldwide what share each language uses, the fact that it's in the top 10 is pretty impressive.
The fact that PHP has a beat makes me kind of sad.
Yeah, PHP has a beat, but that's because web stuff, and that's okay. We'll live with it.
WordPress is built on.
Yeah, there's a lot of major websites that are built with it. But
Swift already 9th. How is MATLAB in the top
that's
10?
not the point. That's not the point. The point, we're talking about R today, and R is lucky number 7, and we're going to keep going. So this actually has a pretty wide use, especially with big data and all those buzzwords popping up. So what do I do with it? I got R. What can I do with R? And I think that was the end of the slides. So
what do I installate?
What
do I installate?
you can install RStudio. So first thing, obviously there's online compilers. So R is a interpreted language, and because of that, you can have online interpreters so that when we do some hands-on programming, you don't even need to download anything, and you can already start creating plots. And if you look, this is a total of like literally 4 lines of code, and one of them's bringing in a library, and you already have nice plots. So if you have data that's too big to put in Excel and you need to graph it, you need something powerful, and I think R is that tool. So you can do this kind of generate your plots one at a time. That's nice and neat. You can also, this is kind of one of the big things with R, at least for me. Let me pull it up. This is what's called an R Markdown file. I'll probably zoom. Can I zoom in a little bit? I don't think so.
Well, are they marked down?
R Markdown. Yeah, I can zoom in on this. So this is like the sample file that it creates. And this is where R can start to shine, because R isn't just you're creating graphs, you're doing statistics. You can really use it as a full way to communicate whatever you're trying to show with your data. And so you have things like R Markdown, and I'll show you what R Shiny looks like. But essentially, it gives you this ability to, generate HTML, PDF, or Word documents, and include your data and your visualizations. And then, because your code is mixed with what you're trying to show, mixed with your, the analysis that's generated from the code, because you have all that mixed together, it makes one cohesive way to show non-programmers whatever you're trying to show. So it doesn't matter if I went to a business analyst, I went to another data analyst, I went to the CEO, or I went to some programmer. Everybody can look at this in one cohesive document and understand what's happening and see what I'm trying to show. What's up, John?
Can I call R code from other languages?
Yes, you can call, I believe there's a way to call R from Python and Python from R. I've used, there's built-in support, well, there's stuff that you can use R and C together, which I've done before, where I have my R code call C code to generate the data, which then brings it back into R to analyze it.
So if I have my C,
Yeah, I use that for the hackathon. So, and I have a couple examples I can pull up at the end too.
So if I have my C code call a piece of R code that calls C code, does that mean that I've got an RC circuit?
Whoa.
This sup.
With this, is it just very similar to like Jupyter Notebook?
Yeah, it's exactly like a Jupyter Notebook. In fact, I believe you can make an entirely like Jupyter Notebook style examples. So here's a bunch of different files that our studio specifically supports. Our studio is like the development IDE for R. And so there's a couple examples. I don't know if you guys can see it. So you can make R scripts. You could make an R notebook, which is that, it's like a Jupyter notebook. R Markdown, which you just saw, which is rendered instead of like having it, so it's like an image file at the end as opposed to running the code. You can make web apps, and then
R64 or R?
what?
R64 or R?
R. I don't know what you mean by R64.
Because it's telling you to choose the R installation.
Oh, you should have R.
Like 32-bit R?
Well, you probably want 64. I don't know.
Depends on your computer,
Yeah.
I imagine.
Okay.
The other thing this has in here, D3, which is a JavaScript library for doing data analysis, and a couple other things, including like R presentation, R HTML. So there's a lot of different ways you can take R to create whatever type of document you need. But that's the thing. It's not creating, a lot of the times it's not creating an application. I'll show you in a little bit. You can do that. But a lot of times it's just creating a way to communicate whatever you're trying to show with your data. And that's really powerful.
So it like processes data and then outputs that into
Yeah.
easy to read visualizations
Yep.
that you can include in like reports
Yeah,
or
it-
websites. Or,
It creates a way for you to communicate whatever you're trying to communicate.
that is really cool.
And that's kind of why R, I think, really has still stayed popular, is because it really gives you a good way to communicate data, which is pretty much running everything we have right now. The other thing that you can create with R, which I have running back here, you can create like online applications for analyzing data, and you can.
Rotate that in real time.
Yes, you can rotate that in real time. So this is another thing. R lets you play with the data, and that's important, especially because if I gave you this image, how far back is that line? Because it's in 3D. It's a 2D rendering of a 3D image.
But even just a second render gives you an idea of where it is.
Yeah, and being able to fully go in and immerse yourself in the data. In fact, I have a couple other ones. This one lets me change, what I'm plotting two variables against and then generate the data. I have no idea what this graph means. But now I have the ability to just keep generating different graphs, and maybe I can start piecing together. Oh, I can look at this one, and then I can adjust this and generate this graph, and I can say, okay, that's interesting, and then I can start, there's this playing with the data and really trying to put together trends that you wouldn't normally be able to. So, are you trying to figure out what this is?
Yes.
I don't have time to explain what this is right now. This
Okay,
is
that's fair.
this is my work data.
That is a really neat looking formula.
Yes. This one's also pretty fun. You can watch action potentials propagate. Technically, this is in reverse. And then, so this is probably a total of this entire web page, which includes all 4 tabs. Actually, you can also change what data set you're using. Is running right now in a terminal. And so I have in the top right is the actual application running. In the bottom right, I have htop just to make sure I don't do anything stupid. And then on the whole left side is basically my R code. And it's a total of 327 lines for the entire application.
With all due respect, that looks horrifying.
So
That's mostly because of the column left.
the column wraparound makes reading this horrible. I also made it larger. There's some things you can do when you're building R code that can look like syntactic garbage that I'll sometimes do, but it's kind of partly because you're kind of never really running your code a bunch of times. unless it's like a big application. If you're just trying to generate those graphs,
If parallel-
it's like a one and done kind of thing. So you can write this kind of garbage style, but you can still get good plots out of it and then take that apart and edit it and clean it up.
Yeah, it's not like an application that you're gonna be revisiting and trying to figure out how it runs 6 months from now. It's just like to generate visualizations.
Yeah. Yeah, but if you are planning to work on something, obviously you keep your code clean.
It's supposed to parallelize as much as possible, isn't it?
R?
Yeah.
No.
Really?
It's not necessarily efficient. But there are some things that you can do to make it efficient. There are because the looping in it isn't necessarily efficient, but you can actually generate code that then parallelizes loops and stuff.
Is that why you had it called C? Because C could parallelize
So
stuff more.
actually, the reason I was doing that, so I can bring up a GitHub repo of using R and C together in what I think is kind of the perfect harmony of the two. And so it's on my playground, and so what I essentially do is I have an R script that calls R, or it calls my executable that was generated with C. So this one doesn't necessarily generate actual C functions. You can do that and call compiled things, but what I did was I combined using C to generate data very quickly, and then use R to create a beautiful way to show that to people. And so it's the combination of efficiency, because I have to generate a lot of data, and then the beauty in being able to communicate them. And putting them together in R is really what I think is what it's meant for. And then I went a little farther and used OpenMP in some of the C code, so then it's stupid efficient C code that's then generated with an R Shiny app. So now it's an interactive application that generates code that generates data stupid fast, and then you can analyze it in a way that makes sense.
Very cool.
So, well, we can start playing around with it if you guys want. So you can pull up, I think I dropped a link in the Discord. I think, yeah. So if you want to go to that //snippets.
So we're not supposed to.
You can download RStudio if you want. That's probably better.
It's already running out here.
Perfect.
The main thing is like how I turn on dark theme. I'm going crazy right now.
Yeah, dark theme. I think I had to go to 5. Where was it? It might be in Tools. Tools, Global Options, Appearance. And then it's Modern, I think. What else did I have to do?
The classic, which was different.
Yeah, I think that's everything.
I did actually download RStudio on my desktop, but I don't think I've ever actually used it.
It's fun.
With the exception of me following the tutorial I told you about.
Yeah. Okay, so if you are using RStudio, most of this you can type in interactively in the console. You could also theoretically just open up and, so if you're doing things, a lot of times if I'm just kind of playing around and I'm just trying to get an idea of what's happening, I'll just get a clean R script open, and then I'll type in commands like, so we have to import some data sets, and what you can do is on every line, as you write it, if you hit Control Enter, it runs it in the console. And so a lot of times I might write a bunch of code, hit Control A, Control Enter, and it'll run all my code for me and generate the plots. So if you're using RStudio and you want to get that interactive feel, but you want to have like a clean file at the end, that's what I recommend, is using Control Enter to do stuff. And that's actually what, not this, is what this website actually has as the hotkey, which I really like to run the code. It just has you press Control Enter. So.
Okay, so I got the dark theme to work in the editor, but not in like the window UI of the editor. Only the text field.
In the window UI of the editor, only
Like
the text
basically
field.
this.
Did you hit apply?
I did.
and then you might have to restart it if you want to get the full team. Okay, so I'm going to get started for everybody who's getting ready. The first things are loading up your libraries, and the two I'm going to be using are the ggplot2 library and the well, there's going to be three actually. So there's a data sets library where we can get our data, and library dplyr, which has a couple cool functions that we'll look at. I don't use it too often, but it is a pretty, I've seen a lot of people use it before, so it's not surprising that they have it. And so you should be able to hit run, and it should run, and it'll give you like things saying it's attaching things, but yeah. If it does not have the library installed, which I'm assuming it probably won't if you're not using this online thing, you do, let me make sure I get this right. It should be install.package. No, okay, it's install. Yeah. So what you should do, if you are, I don't know why I keep opening it. It's install.packages, and then put the name of it in quotes. So you might have to do like that. And that's how you can install packages. You should only have to do it once, and then it'll be on your machine. It uses what's called the CRAN project, which is a comprehensive archive network, and essentially goes to one of the mirrors and downloads the code for you. It's really useful, and it lets you get all these libraries super easy. It's like pip installs are nice and easy. They're pretty easy in R to do these kind of installs. So we got the libraries in there, and the first thing that you probably want to look at, what's up? You got everything running?
Yep.
Nice. We can do data iris, and so waiting queue running. So that just loads up. So the data.iris uses the datasets library to get the iris dataset. If you don't know what the iris dataset is, it's a set of a couple variables that were measured by a British statistician and biologist Ronald Fisher in his 1936 paper, The Use of Multiple Measurements in Taxonomic Problems as an Example of Linear Discriminant Analysis. What a page turner. But essentially, it's really a common data set that's been used in a lot of, you might even see it in machine learning examples and other things like that. It's really, it's become a widely used data set because it has some really basic things in it, and it's not too large of a data set that it's overwhelming to use, but it's not so small that it's like, why am I not just an Excel kind of feel? So that's why I like it. I don't particularly like some of the variable names because it has multiple words in them, but it's okay. It's a nice data set though. There's a bunch of other ones in this library that you could use as well. So first thing that's always nice to do is to do a summary. So a lot of times in R, there's no semicolons, none of that. It's basically just read line by line. And so the summary will give you kind of a look at your data set. And so you can kind of see it listed all the different variables. So we have 4 different variables, the sepal length, width, and then petal length and width, and then it gives us species, and it gives this, the summary gives you some statistics on them, and actually it gives you a pretty decent number of statistics that really let you, without having to do that much, you can get a good analysis of what's going on, which is nice.
Quick question with RStudio.
Mhm.
Does that install R also?
RStudio, I believe it should install R, but
It doesn't.
it doesn't?
You have to install it, you have to
Okay.
download it from Mesa Case.
Oh, that's kind of annoying. I forgot about that.
So where do you get it?
There are multiple places you can get it, but one of the install mirrors is from Case in Cleveland.
When I get there.
You should just be able to
You gotta
download.
drive down to Case Western Reserve
Stop.
University, and you gotta arrange a meeting with someone in an alleyway.
Yeah, you should be able to
You
go to
gotta
r
exchange
dash
passwords
project.
with them, and it's gotta continue
And to
exactly one
download
line,
R,
one
please choose your
line.
preferred CRAN mirror.
And you gotta make sure.
Please stop, John.
Okay, fine.
God.
Sorry.
Yeah.
C-RAN mirror.
Yeah, it'll choose, and then it's just like, there's various locations. I believe there's a bunch for the US, and one of them is Case Western.
What is C-RAN? I'm not sure.
CRAN is let's see if I can get the it's the comprehensive, it was right here, comprehensive R archive network. And basically it's all these servers that have a mirror of it to
So
download.
what's the script you want me to run?
So we're gonna write it. So first we have there's a few lines. I'll zoom in a little bit so you can see it a little better. Right now we've just loaded 3 libraries. We loaded the iris data set and we printed out a summary. So that's nice and neat. That gives you kind of an intro. So now we kind of got our workspace set up. We can kind of start getting hands-on. So what should we do first? Personally, I like plotting things, but it's probably good that we do some statistics. Me a little bit. Obviously, the summary gave us actually a pretty good number of statistics, and I am not trained in statistics enough to go any deeper than a lot of these. Theoretically, you can go into like standard deviation and stuff, but that goes a bit beyond what I use R for.
So I can make diagrams for engineering stats and put in my silly little notebook.
Yep. So the first thing, we're gonna make everything lowercase, just so it's easier to type. And this is where we can kind of see the weird things that R has. And the first one being the arrow operator, which is the preferred way in R to assign values to a variable.
Is the to lower function, is that capital L? Or is it
No, it's a lowercase l. It should be. Let's make sure. It should run just fine. Yep. So that's set up. It's the preferred reason, and the reason why we use the arrow operator is because then when you do functions, a lot of them you can assign specific arguments, kind of like in Python where you can pass specific parameters and say x equals this value and y equals this variable, and you can send them in whatever order, and you just assign the variables that you send. That's used a lot in R, and so we usually use the arrow operator when we're assigning things, and we'll use the equals operator when we're specifying parameters in a function, and that just keeps it clean. You can the equal sign and the arrow operator, at least in this case, are the same. You can put an equal sign here; that's no different. But when you're doing function calls, you can't. So the next thing, we can start doing some fun things, like we can filter the data. So this is the Virginica. Let's see if I can spell things right. Virginica filter, and then it's the iris. So we're passing what data set, and then we're specifying one of the parameters, Virginica. And then we can do head Virginica. Anybody want to make a guess as to what head does?
First element?
Close. It's not necessarily, it's not just the first element.
Second element?
It's going to list a bunch of the first elements. 6, I think I've seen sometimes it might go, I think it always does 6, and you can actually specify how many you want it to show you. So let's say I have a bunch of data. I believe I can put 10 in there. And that should work. And then it sends me 10. So the head and summary, and then we're going to look at tail in a little bit, are good ways to kind of look at your data set and just be able to see, okay, is it the shape I know it should be? Which is really useful. And also you can see we specified species should be the Virginica, and now they all are.
Is tail just the opposite? It's like the last one.
So we should be able to just switch this out with tail. And I believe everything should function as normal. And there you go. So another thing that, since we use tail, we figured something out. There's 50 of them that are Virginicas, which is cool to know. And also that matches, what our summary says. So that's, you can kind of do these things where as you're going along, you can check yourself. Check yourself before you wreck yourself.
Does R have like a print function like Python does, just to print the console?
Yeah, you can do cat, and actually I believe if you just do this, if you just type in a variable, I believe it just prints the entire thing out to the console. So if you just have a variable there, it just prints it right out, which is nice because of that interpretive style, that you can just enter things line by line and just say, okay, what is this variable? And just type the variable in. I can type 2 plus 2 and it'll just return 4 and just print it to the console
If
kind
I
of
just
thing.
wanted to print like a line of text out, I could just assign it to a variable and write the variable. out.
Yep.
So you can run it in a real-time console, same as like
Yeah.
Python.
Yeah, and that makes it really nice when you're just like, I don't really know what graph I should be making right now.
Yeah.
I just need to make a graph and figure out what's happening in this
You can
data.
use it as like less of a programming language and more of like its own standalone application.
Exactly.
Very cool.
And then once you've figured out what you want to do with R, then you can take that knowledge and create R scripts or create your R Markdown or create your R Shiny app that then really fleshes out your idea.
Very cool.
Which really isn't something that you could do it in Python, I guess. I don't necessarily know it would be as much fun to do. I don't think the graphs in Python are
Or
nearly
it's
as
like
nice.
specifically designed for this stuff.
So I'm just going to keep piling stuff on in this, just so that we can kind of see things being built as we go. So we looked at filtering things, which is useful if you're looking at like a specific subset of your data. What else can we look at? New column that stores logical values. Oh, okay. So a lot of things are stored in vectors, or in this case I'm going to call them columns. And we're going to use what's called the mutate function here. And so I'm going to type this out, and then maybe we can look at again, I don't use all of this, so I should probably spell things correctly though. So I don't normally do this kind of thing. So.
Are you genetically altering the flowers to have bigger petals?
No. Oh man, that'd be, yeah, mutate, not in the species sense. So essentially what mutate does, a lot of it is it takes data frames and changes their shape in some way so that we can then manipulate it in a different way. And in this case,
Like a linear transformation type thing?
yeah, kind of. It just puts it, really it's just manipulating it into a different form. It's not actually changing anything. In this case, it's creating a new thing actually. And so what it does is it creates a new column that stores logical values for sepal width greater than half of this. So it looks at logically whether the sepal width is greater than half of the sepal width, and then it creates a kind of true false. So then what we can do, nice, is to just kind of give head. And so I don't necessarily know exactly what this is going to look like in my head. So I'll use head so that I can make sure before I go any farther. Oh, we now have this new column called greater.half. And it's true when whatever that function is that we created.
So does mutate just return the result of the script that's passed to it?
Yeah.
Put it
And
into
just
like
kind
another
of
data?
puts it in. Yep.
Very cool.
Really just kind of tacked it on to the end. And there's a bunch of other things you can do that you can get into. And a lot of it, especially when you're loading up your data and it's in this gross format and you're like, I don't need all these columns here, and they're really just kind of messing up a bunch of other stuff I'm trying to do. Being able to take your data set and manipulate it exactly how you need it is really important when you have really big gross data sets. So,
In RStudio, how do I run the entire script as opposed to just the current line?
I believe what you can do is well, so first off, you can always do Control A and Control Enter. There is a Run button in the top, which you can use.
But that runs the current line or slash.
Yes, I thought one of these, we were on the previous. You might just have to do, I think you might, can you do F5 possibly? Or just Control A, Control Enter runs the whole thing. So,
Gross.
yeah. But a lot of times you aren't running a whole script over and over because every time you run a line in here, so if I do like data set iris and run it, you can actually see, so it gave me an error, oh well they gave me an error because I didn't load up the data set. But you can see my current workspace right here. I have a bunch of stuff already loaded. And so a lot of times when I'm playing with my R code, I have my pre-written functions loaded in the background. And I'm like, oh, I want to look at this data and apply this function I've already written to. I just call that function because it's loaded in memory right
It's
now.
kind of like load in your own personal little toolbox.
Yep. Yeah, it's literally my own little toolbox. That's a perfect way to look at it. And then I also have my giant data sets that are like 20,000 lines, which I'm definitely not opening in Excel. So,
How much RAM would it take up in Excel?
so they're in CSV files right now that are about 1/3 of a gig, some of them, and it takes a hot minute for Excel to open that up.
Quick hot minute or slow hot
It's a
minute?
slow hot minute.
Even on your computer?
Yes, even on my computer, both of them. It takes Notepad a hot minute to open up that file. Yeah, have you ever seen Notepad load?
Notepad is like Ed, but slightly faster.
Okay, so we're going to continue looking at R, and really I want to get into the stuff that I care about, which is plotting. So we've already loaded our ggplot library. We've already looked at doing some basic manipulation, looking at the actual data set itself, and we've kind of taken it apart a little bit. And so now we have, since we have the ggplot library open, we can do is, so really these plots, what you're going to see is kind of this style, where I have things and I'm kind of adding them together. This isn't the actual code, but I take the ggplot as kind of like my base, and then I just keep adding whatever I want to it. If I want to add this path, which is, it's like a line on top of it, so now in this I can pass it, whatever data, I can pass it the data set here, or whatever X and Y are. And I can just keep piling things on top of it.
Is there a reason you're not delimiting with spaces, if I may ask?
Adding spaces, because you can just keep piling things on. Normally, what I would like to do when I do this kind of thing is I'll put it on a new line and I'll add a tab, but it's kind of hard to do in this editor. So that's what I would normally do if I'm in so I'd take this and go over to RStudio.
Is this what you meant by writing garbage?
Yeah, you can, because you can just keep piling things on for this graph. And maybe I only ever need to generate this graph once, and I'm going to delete this code afterwards, then it might be okay.
But it's
If I'm
still
delete-
good to just be able to reproduce it.
Yes, you should, you should, and that's why when I do things, usually what I'll do is
Indent with a tab or
I'll indent. I think sometimes I'll put the plus on one side or the other. I can't remember which one I normally do. I think I put it on the end so that when it reads, it goes to adds the next line. So this is a lot cleaner version where I took ggplot and I'm adding things to it as I go.
so
And that's,
you're basically saying at the end of the line, hey, I got other things.
I got other things I want to add. Yep.
So basically, there's no standards for how you're supposed to write the language.
There are, but a lot of the times, But a lot of times I'm just trying to make a graph, and I need to make a good graph, and I don't really care about the code sometimes. When I'm making my R Shiny apps, I definitely care about the code. And when you look at that code, I try and keep a nice style with it. But that's the thing with R. It's not always generating applications. It's not always trying to build a pretty document. Sometimes you're making a gross, just trying to figure out what you're doing. And having that freedom in R to be able to do whatever you need to do at whatever time. It's really nice, and you really don't get that with other languages. So, back to generating some beautiful graphs. So, first, this is kind of why we were using that operator, the arrow operator. So, like in Python, you can pass specific parameters and set them equal to things. This right here is not the it's not the same assignment operator as before. And that's why you use the arrow operator in certain instances for style, and you use the equal sign in this case, not because of style, but because this is what you actually have to do here.
So equal is parameter definition, but pipeline is basically just kind of, hey, we're just aliasing all this crap to this thing.
Yeah, the arrow operator is just assignment, and technically it can return the value, but you use the equal sign in this case, you use the arrow operator in this case, and that keeps the style clean.
Okay, that actually makes sense.
So that's why you do it. It's neither here nor there, it's just what you should do. And so we're going to define two things right here. We can set the x to be the species, and remember we made everything lowercase. If you ran that, if you didn't, then you can capitalize these things. Sepal, if I could type length. So, what have we done here?
I
Well,
have no idea.
we created a ggplot, which is kind of like our base. We set the data set for it, and the aesthetic thing essentially lets you define your x and y, and for certain things I think it can even go to z and other stuff. But so this is kind of primed our plot. It's primed up. It's got the data set in it, so we don't have to do iris and then the other operators to try and get to the data we need. We can just use the data we need.
Okay. And GM path and GM point basically say we're plotting these points in space, and then we're also drawing lines to connect these points. That's what I'm getting?
Yes. So actually, the first thing we can look at, this one was, I ran this one and I was like, oh, this is really cool. We'll start off with the scatter plot. And so we'll add geom points, and then what we can do is we can go one layer deeper. This one actually might make more sense if we plot sepal.width against the length. So we have length and width, and then we'll do the color equals, species. And really we could stop here and call it a day. Actually, let's see if this should run if I did everything correctly. Yeah. See this? Look at how, this is a pretty plot.
It runs on my machine.
Yeah, and it's a pretty plot. I'd be pretty happy if this was generated in Excel and it was one line of code that I did. I had to obviously had to load the data set in, but it was one line of code to generate a pretty graph. And I think that's pretty cool. And then it's like, then you look at the picture and you're like, wait a minute. Why the heck is this color only over here and the blue and greens are kind of mixed together?
So where's the data coming from?
The data set itself?
Mhm.
Like where is it loaded, or?
Like, where did it come from? Did it come from UPRC?
It came from the data when you loaded in library data set. And then when you use data iris, that's when it's actually loaded in your workspace. So you loaded the library up here, and then you loaded the data set into your workspace down there.
Okay, I'm a special boy, I'm sorry.
That's okay. But that was nice. And then you can just kind of keep tacking things on there to keep building things, and especially if you're adding one variable at a time, it makes it easy for you to figure out. It doesn't necessarily make it easy. So if I then go in and you can add What do I want to add? Yeah, I can add in shape.
What if I do data equals negative iris?
That's not a thing. So then I went in and I added the shape, which should be, so it's a little hard to see. And then, okay, well that was a little hard to see. So now I want to add size. Can I add in?
My plots are vertical.
What do you mean? Are you using the online thing?
Yes.
That's probably why it probably specifies its area. If you do it in our studio, so actually why don't I just copy this and load it up in our studio so you can see.
Big shapes.
Did you make the whole thing?
Mm-hmm. What if I make it 10?
And then what I can do is actually, it's really nice because it'll resize it automatically and then it re-renders the image. So I can zoom in on things and adjust it. I don't know what the online compiler does for generating the image, but if you use RStudio when you do really want to get into it, it's really nice actually. And this is really a pretty graph. And you can go in and then you say, okay, I actually might want to save this. I can then just keep tacking things on. So I can set the X label and I can actually make it like a nice
I want to work in data science now.
width, and I don't actually remember what the units were, but you can do this kind of thing. And so now if I grab this line, because I've already run this script, so I've already loaded the data set and I've already done all that, I can just run this one line and it generates the new graph and you can see the cleaner, labels on it. And so you can kind of keep tacking things on until you get a nice clean image, and then you can save the image. And actually in RStudio, this is also pretty nice.
So what's the YLET supposed to be?
Save it.
That's legit.
And then I can save this image. And so I've been playing around in R, and now it's all pretty, and then I just save it to my wherever I'm working.
That's really cool.
Yeah,
So
that's
what,
powerful.
what does this data even mean?
That's a good question. And a lot of the times that's what data science is what does this data mean?
No, what I mean is, what is...
It's looking at flowers. And so we have the sepal width. I can't remember what part of the flower is the sepal. And we're looking at width versus height, or width versus length. And then we have color is the different species. And so maybe you don't care about any of this, but when you graph it, you can tell that the Setosa species seems to have a very different, relationship than the other two.
I don't even know you need to know what this data is to be able to plot it.
Yes,
I
but
just import someone else's data set.
but you can see how much more important this is what if this is the sales of your company for the last couple of years, and you need to figure out some way to, if this is maybe all the different quarters and each color is a different marketing group,
You need to argue what decision made your
you need to argue what $1 million decision your company needs to make. You need a good graph that can show people why you need to make that decision. And that's an important thing. And being able to make a beautiful version of that people are, I don't even care what the data is. I want to look at it and figure out what's happening. If you can get somebody drawn into your data visualization without them even knowing what's happening, then you have a good data visualization. If they're already drawn in before you've even made your conclusion, then you're golden. Because then they're going to stick around to figure out what you have to say. And that's powerful. That's a lot of power.
The sepal is the middle part of the flower with all the pollen on it.
Oh.
And apparently, according to this data, setosas have short, stubby staples and kind of short, wide staples.
Yep.
And
You can see
others
the
have
width.
kind of narrow, long staples.
Yep. And that's exactly what you see in the data set. So it's quite
Oh,
interesting.
I mean, I extrapolated that from the data set.
Oh,
not
there you
from
go.
Wikipedia.
See? And you're learning something. So, this, see you, man. So, the last one that I thought it was really cool. And I hadn't actually used this specific one. So a lot of these graphs that I generate here are just basic line plots. And then essentially all I have is every time I send a new image with different variables, it just grabs a different X and Y value and throws it into ggplot and generates it. In this plot, I didn't even bother trying to figure out how to make a line with points on it. I have a geom line, and then I add on top of it a geom point. And then I just add the two together and I can get this nice shape. Because if I just had a line, it wouldn't necessarily show me where all the points are. If I just had the points, it wouldn't really give me that full connection. And so you can add things to really fit whatever you're looking at. And 3D, being able to, play with it, because 3D is better if you can really rotate it and figure out what's happening. It's just this one variable in that long string of them, which admittedly gets gross.
Then
But
you have like the color that lets you do a fourth dimension.
yeah, exactly. And then I could even with this, if I was doing a scatter plot in 3D, I could do nice.
Look at this.
I could do shape, I could do color, and then I have 3 dimensions. So now I have a 5D image.
Wow.
And the more dimensions you add, the harder it is to interpret what's happening. But if you're knowing what your data set is, you can play around with that. I can go to 5th dimensions because I know what I'm looking at. It's going to be impossible for me to explain it to some CEO.
But if you have
But-
clever ways to generate the visualization like R does, like with
Yeah.
the different shapes
Yeah.
and colors and all
Yeah.
of that,
You
then
have this,
it can get self-explanatory.
Exactly. So the last one, which I had never used before, but I thought it was really cool. So this is really just giving you guys a taste of what R can do. We're going to look at a box plot.
Frank, our expectations are high.
So again, we're going to start off with that, a very similar,
I haven't played with box
Look at-
plots since the ACT.
species. So we're going to, X is going to be species. Y is sepal, or no, sorry. It was the histogram that I really wanted to look at, which has a slightly different base. X equals sepal dot width. Okay, so we got our base. We got our base ready. Now we can get real fancy here. Histogram, and we can set bin width to 0.2, and we can set the color equals black, and then aesthetic fill equals species. Let's see if this runs. Remembering to do the correct number of parentheses can be hard, because you can get real deep in it. Did I do it right?
Wait, what does AAS have?
It has a fill.
So GM histogram entry, bin width equals 0.2, color equals black, AAS parameter, fill equals species, and end.
Yes,
Making
that
sure.
should be right. What did I miss?
Error in layer.
It says black, not found.
Oh, it's supposed to be in.
I see we're not
Quotes.
very progressive here.
No, it's in quotes. So actually, in colors, you put them in quotes.
Oh, it's like
You can
CSS
send
in it.
strings.
Ring.
You can send them as RGB values, which I actually do sometimes if I want to get specific. So that's another thing. It's like
It's like CSS in it.
it has that styling. It has I can put in black. If I don't want to go through and find the RGB values, I don't want to. But if I want to, I can't. So if I want to make my graph match our, whatever our company's logo is, and there are specific coloring, I can do that too.
Can I do overlay graphs?
Yes, actually.
Best fit curves.
Yes.
Like
You
a
can do best fit
sanity-
curves. You can do a lot. This one is really fun if I can get it. Yes.
Oh boy.
Look
I
at
got
that.
in my machine.
Look at that. Look at that histogram.
It's so cool, actually.
You're like, huh? Isn't that interesting that this, the Virginica has this kind of nice one, and then you see this kind of divide that's happening between the versicolor and the Cerbosa.
The white boys average around
And-
2.9. Virginica's average around 2.9. The versicolors average around 2.5, 2.6.
Yeah. And I mean, we got that we got those data points from the summary.
Asymptotes.
But
Why
sometimes, but looking at the mean and standard deviation, sure, it kind of gives you the normal curve, but there's something different when you look at them all together. Then looking at numbers really don't.
What if we were to make 3 best fit curves and then just add them all to each other?
You can do a lot of scary things in R. This is just a taste. If you want to get more in depth, a lot of it is having a cool data set to play with. And there's actually a pretty good number of sample data sets. So this is the IRIS data set. They have a CARS data set, which looks at like gas mileage and stuff, which is kind of fun to look at because it has like trucks compared to like, you know, normal cars. And so that was interesting to look at. So yeah,
Passenger drones.
yeah. Is there any questions? Any other
Can we
things
do
to go over?
object-oriented programming in R?
No. Well, you can. So you can do objects, but really you just use data frames. And then what you can do is you want a specific thing from the data frame. You can do, I didn't show you guys this, but the cache sign. So I'm going to comment out. You use the pound sign for comments. I'm going to comment out a lot of this. And then you can put in whatever name width of a column you want. So this should work. And then it's just going to straight up print out. What it did was it literally took all of the values in that column from the data set. And normally I would like assign it to a vector or something. But if you don't assign it to anything, it'll just normally just print it straight to the console. And so that's what it does. So it printed a 150 thing that's all of these, whatever I printed out. What did I print out? The sepal widths. All of them just printed right out to the console. And I can assign it. May I want to take that and assign it to the x value. May I want to assign it to the y value of some plot. Maybe I want to put it into a vector and then start doing math with it. Like, what's the squared of these look like? Is it some fancy thing pop out at the end? I have no idea. Can I take like the partial differential of the sepal width with respect to the sepal length and get something out of it? Probably not, but you can see where you could go with that if you had data where that would make sense.
We actually went over in image analysis the idea of discrete level gradient.
Discrete level gradient. Okay, we're not talking about that.
I know, I'm just like saying, it's
So-
possible and there's talk of it.
I know. So yeah, anything left? I think I covered everything. I didn't get nearly into any of the stats stuff you can do. You can do some pretty ridiculous stuff, and it's really easy to do, which is part of why R is nice.
Why do
So,
setosis have wider sepals on average compared to everything else?
I have no idea. But now you want to know, don't you?
A little.
And so that's what R is great. It makes you want to. It really. There's a reason I say it's like playing with data, because you really, when you start getting into it, it's like you forget that you're coding and you realize you're just looking at data, and that's a lot of fun for me. So
Our files, they have, is there a file extension .r?
yeah,
Okay.
so there's a, let's see if I pull up R Studio.
Are you sure?
Yes, I'm sure. So our scripts are .r files, and you can just like I think in my it's the R Shiny app, I actually just load up an entire different R script that has my useful functions. I don't even think I use half of them, but I've just had a useful functions.r file that I just load, and it has all my useful functions that I need. Our markdown is .rmd files. Our Shiny apps are still just .r files. And the rest of it's pretty standard. I don't remember what the extension is for a notebook. Save. Sample notebook. It's probably, oh, it's still a .rmd. So notebooks are just run a little differently, as opposed to being run in just when you do an R markdown, you just export it as like an HTML or a PDF that's like a static thing. With our notebook, it's interactive. So all the code you write, then people run it as they go through your document. So it's a bit more technical than and our markdown would be, but maybe your audience is more technical. And so that's another, I mean, it's, you're looking at data and then you're communicating it to people. And being able to do both is really important, because if you can't analyze the data, you're not doing anything. And if you can't communicate your data, you're not making anything happen. So, yeah. Yeet.
Thanks.
Yeet. Okay.